Alright, well this is my new Planet set, fresh out of the bath, to get all the packing oil off of it. Believe it or not, it was cheaper to buy the complete set than just to get some of the components that I needed. So, that's where I'm at. This ring has got a conical shape on one side. It goes down in here first, like so, followed by this snap ring. Try to get this with my fingers. Double check it. Good to go. Alright, well I've stuck these two pieces together just like that. I need to drive this down through until it seats. You can't see, but I'm still supported under there, but I've moved my blocks so this shaft can go down and seat. I don't know how this is going to work out, but we're going to give it a go. My setup here is a little bit precarious, but it is what it is. Let me try to lightly tap on this, see if I can get it started. Okay, now I'm going to switch to this inside and hit there, but I've got to make sure that I don't jam this cage in there. So I'll drive it down just a little and I'll try to get the gears set to where I can maybe try to hold it up. Drop my piece of copper in here. Not really any good way to hold things, so we're going to try it, see what happens. It's going. Still got room. Still looking good. Starting to get snug. There we go. I'm going to try to hold up on this if I can without hitting the edge of my hand here. Hopefully that copper will stay put. Ow! Saw that one, didn't you? Do I have any pliers here? Bear with me, guys. Winging it. Try to hold this up if I can. Keep my hand out of the way. That hurt. Everything is still free. Doesn't feel solid yet. I think that's it. Yeah, that's definitely it. One more for good measure. Yep. Ow, that hurt. Alright. Now I believe I need to flip it over and tighten the nut on the other side. Alright, well I've got it flipped back over. This retainer goes on right here. And then this nut. The socket I think was $130 to $180 for this. I went down to O'Reilly and just so happened they had a 9-pin four-wheel drive hub socket. And that nut almost fit in there. So I just took a file and hit those a little bit deeper. I've made it snug. Get that on there. So you can see that's going to work out just fine, I believe. That goes on here, and then I'm posed with another problem. If I can get this started. Come on. There we go. I've got to put 207 foot-pounds on this, but I don't have a big spanner to go across or around here, a pin spanner to hold this gear. So I'm just trying to figure out a way to do that, and I don't want to wedge something in here too terribly hard because I might end up breaking the case. That's a lot of torque. Let's try this here and just see. I don't know. I don't know what to do here. I don't want to have to make something, but I may have to. Let me figure it out and I'll describe what I've done. Alright guys, well here's where I'm at. I didn't realize that my kit came with a new nut. I don't know if these are torque to yield, so I went ahead and dressed the new nut and got it ready. This is the original nut. I started working out my system to tighten the nut up here, and I was getting there, but then things started catching and binding, like the bearings were binding up. So I went ahead and drove this back out, and I don't know if it's going to show up here, but here's what I've discovered. If you look at the end of my pick, you see where this weld extends out beyond this shiny ring, and you can see that shiny spot. That's where I'm compressing weld material when I'm trying to tighten it up, and I believe it's causing the bearings to turn and bind a little bit because the bearing race actually resides right on this shiny ring. So I'm going to grind this a little bit and dress this up to make sure my bearing is going to happen right here and not contact the welds. Alright, just a couple minutes with a roll-lock abrasive wheel on my angle grinder, dressed those welds up. They feel nice and smooth now. I went ahead and addressed the ones on the inside as well, just to make sure that anything in here that might be spinning around wouldn't contact those. So this piece looks good now. Hopefully that will take care of the problem I was having. We will find out. Alright guys, I finally got it to click at 207 foot-pounds. What seems like that in a video has been literally hours of me futzing around with this trying to get it done. I'd mentioned there was a particular spanner socket that would go into these, like a pin socket. You know, they're 525 bucks. So I've been working on everything else. This is one of the webbings from my ratchet straps. You can see it's severed. The way I was going about this, and it didn't turn out, I'm just going to describe it for anybody who might be interested in how my twisted mind works. But this slot right here, I was coming up through this slot and I was wrapping this webbing around the gear onto itself. I'm not going to take the time to do it, but it was around the perimeter of the gear. This went back into itself, and I kept winding it up until I ended up with a loop right here. Then I put a 2x4 across the bottom of the case, and that was giving me what I needed to hold that gear steady. But right here in the casting, there's some flash, and that's what cut my webbing. Then I created this little shim out of brass to fit right in that area. You may not be able to see it, it's just right in there. And I started slowly stepping up in my torques, you know, 50, 70, 80, 100, like that, just to make sure everything was going to work. And it was. I got to 170, and then when I tried to get beyond that, the webbing got so tight, it slipped off the front of the gear, and there you go. Put it on, try it again. Put it on, try it again. Well, what I ended up doing, which would have been more simple in the first spot, was I found this chunk of aluminum here. I don't know what it is, just something I have. It's got a hole in it. And it just so happens it will fit right in that little slot. And then I took a grade 8 5/16 bolt and stuck it right in that. I put a little tape on there just in case if it contacted the socket it wouldn't screw up my torque readings. So that wedged in there. 207 foot-pounds on the torque wrench. I didn't torque it like this. I laid it up, block of wood underneath it, so I could get my hand rested up in this top corner. And the torque wrench coming off this way with my body laying into it. Once I got this in there, it literally only took me about 30 seconds. It was all the trial and error before that. Now, I've got it torqued exactly the way they say to do it. If you ask me, the preload feels a little bit tight. I don't know, but that's what it is. Filing down the welding marks on that planetary set did take care of the binding I was having. Like I said, it's a little bit stiff, but I'm to spec. At this point, get my socket off. I need to locate one of these tabs, or two if it's available, bend it up into the notch, and I'm finally finished with the hard stuff. Now it should be back to more tedious things. Alright, I'm going to put this rear planet set together. It starts with this thrust bearing. This flange goes down in first, and it'll lock in that bore. Everything's been coated with an ATF. And then the sun gear has got a shallow ring in it, and then a deep one on this side. The deep one faces up. Get that put in. And then it's followed by this race here that's got a small flange on it that goes down first. And then the thrust bearing. And then a flat outer race. Sets on there. Just going to kind of put everything centered in the hole. And then drop this planet down in. Try not to jam my fingers. There we go. Making sure that bearing is in there, looking good. Now I'm going to have to hold up on this a little bit to get the snap ring down in that hole. But I might be able to get it started first. So, there we go. Okay. Just barely got it started. Now I'll pull up on this and snap it down into the groove. Looking good. If I can rotate it a little bit, I'd like this part of the snap ring to be on this section as well. I don't know if it will fit, but we'll give it a shot. There we go. Double check it. Looking good. Alright, well I need to drop in a set of frictions and steels here, starting with the steel first. These need to go in a specific way. You can see these three notches here. It will start in there, collect over here to these notches, and there it is. I've lubricated my steels, or soaked them rather. I mean my friction material, sorry. And then come in with another steel. Just alternating back and forth until I get to the top. This is again a section where they were not accurate in the manual. They claimed, I think, 4 of these, 4 or 5, but there are 7. So we're going with what I know. Take me a moment to get these in here. I said there were 3 of these. There actually are 4. This is the final steel, final friction, and then we've got the selective backing plate that goes on here, just like so. Now I need to check my clearance in here, see if we're within tolerance. Alright, well the manual contradicted itself. It told me to put in this selective steel. I've taken it back out. Then immediately it says to come in here and measure from the top of the last friction to this ledge. I don't know if you can see it, but there's a small ledge right here at the end of my pointer. Measure from there down to that with a caliper. And I've done that. I've got 116 thousandths. Then you subtract from that dimension the thickness of your last retaining steel there, which is 75 thousandths in my case. So that brings me to 41 thousandths of clearance here. Well, I'm supposed to have between 43 and 48 thousandths, so I'm missing it by 2. I'm a little too tight in here. This is a number 2 steel. They do claim to have a 71 thousandths that would put me right in that 5 thousandths range, but I can't find one. So I'm going to have to just go ahead and run with this being 2 thousandths on the tight side. Surely they engineered a little more leeway on either side than just 5 thousandths of clearance. But that's what I've got to work with, so that's what I'm going with. Alright, well, this apply piston goes in next. There's a hole in the bottom and one in the bottom of the case. Just need to make sure that those get lined up. I've lubricated the perimeter of this to give myself a fighting chance, but it should just drop in there. There it went. Okay, that's looking good. Now this is the snap ring that fought me so hard coming out. There's a bevel on it. It faces up. I believe it came in about right here is where it was when it came out. I'm going to try to get this in there. Hopefully it won't be as big of a fight as before. I'll start this direction. Try to get it started. Try to get it down here without snapping my fingers. There we go. Well, so far it's just happening the way it's supposed to. Alright, that looks good. That was much easier than trying to get it out. Alright, what's next? Alright, this cage goes in here, this shell, and there's wide lugs and narrower lugs. The narrow ones go down first, and it should just key right in there just like so. There's a plastic thrust washer. This is the new one out of the kit. There are 2 extrusions off the back. They go down into these 2 holes. Put that on. Maybe stick a little bit of transmission fluid there. Put that back where it belongs, just like so. I've kind of got everything pre-lubricated. This is the sprag, or the one-way clutch, that goes in next. That groove faces up. It should turn to the left or counterclockwise, but not to the right. That just drops right in here. Try to align these splines. There you go. Now we've got a bearing that goes in. The bottom race comes up around the edge, and this is just kind of a hard line right there. This is the way it drops in, just like that. Now we're moving into this shell. A little bit of transgel to hold that thrust washer in place, because I need to flip it over and put it on. So we'll drop that in where it goes. There we go. I can see my pin sticking through, so that's looking good. We've got part of a thrust bearing that goes here, just like that. The other race goes to another component. Now we're moving in with steels and frictions. Everything's been soaked. This is kind of a mirror of what we've done before. Drop this one right in there. Bring in a friction. Another steel. Just going to alternate back and forth until we get all these on. Take me a moment to do this. This is the last friction. There we go. And then this is our selective steel that we need to put on the outside. Okay. Now I've got one more snap ring to get in, and then I need to take a measurement to see if we've got clearance here. Trying to look over the top, trying to keep my head out of the way. Okay, that snap ring's in place. I'd like to rotate it a little bit if I can. There we go. Looking good. Alright, well I had to take a couple components back out because I don't have bent feeler gauges and I couldn't get down in there with mine. This should be between 24 and 28 thousandths, and I'm at the 24 mark. If I can get this in there. There we go. Yeah, it's 24 thousandths, so I'm good there. Need to go ahead and put these components back in. Get my shell back in there. My clutch. Okay. And because I took this out, I'm going to have to turn it and get those friction rings to sync back up. Hopefully my thrust washer will stay there. Just trying to get it to key back in. Okay, there's that. And there's my bearing again. Alright, well now I'm going in with the last components before I need to take some more measurements. It starts with this bearing race right here. I'm just going to drop it on there. And then this clutch drum goes in. It's been lubricated. I'll need to turn it to get things to key in with the clutch packs that are inside of this. And that should be it right there. And then here's another thrust bearing that goes on. Again, the race that comes out and bends up goes down first. I'm just going to dip this in my transmission fluid. Pop it right there. Now I'm going to be taking measurements from, to begin with, this race right here. Alright, well I'm trying to determine the end play, and I've already taken all of my measurements. It's supposed to be within 8 to 35 thousandths of an inch. I would imagine very few builders actually go through this process because it takes a little bit of time. I would imagine most just slap things together and send them out the door. But here's the procedure as written. Taking a straight edge, laying across this bearing, come in with a caliper and find your depth here, and then deduct the width of your straight edge, and that's dimension A, in my case 504.5 thousandths. Then on the end cover, measure from this top edge down to where the bearing sits. For dimension 1, mine's at 872, and then again from that top edge down to the casting here, deducting the rule again, I'm coming up with 335 for dimension 2. Then you deduct 2 from 1, which leaves me with dimension B, which is 537 thousandths. Then you take B and you deduct A, and that's your end play. And in my case, it's 32.5 thousandths. So I am within the range of 8 to 35, so we're looking good. And then we've got these tubes we need to put back in. This one is going to reside right here. Try to get that started. Give it a gentle tap here. Make sure that's in place. And then this one goes just like this. That one doesn't feel like it's seated properly on the top. Let me try to pry this up a little bit. There it went. There we go, that's looking good. And then this bracket will go on right here, followed by the bolt. Run this down real quick. There we go, and this gets torqued to 48 inch-pounds. Not much, but there it is. Alright, well, I've installed the new seals in the back cover. They just fit like this. Little trans gel on those. Little ATF here and there. Surfaces are super clean. Bead of automatic transmission gasket maker. This Permatex. This is just what I chose to use. So we got to get this thing dropped on here now. Making sure there was nothing left in there. There we go. We've got 11 bolts holding this on. They show an odd bolt in the manual, but I guess on some of the ears they have a different back plate. This one's different, so I don't have that odd bolt. It would be torqued differently than the rest of these. These are going to get 18 foot-pounds. I'm going to actually shoot this in real time. Just getting them started. I'm going to go ahead and just take them to the surface with my impact gun. We're really close to it. Speed this up a little bit. I've got it turned pretty far down. Let's see if that works. There we go. Switch over to a ratchet. Just get them snugged just to the surface, really. Oh, missed one right here. Didn't see it from where I was. Alright, like I said, these are getting 18 foot-pounds. Just going to come around and give it what it wants. 11 times. Just about there. I believe I'm just got one left. Yep, that's all of them. Alright, well, I flipped the case over. I'm now working in this section right here. I've dug out the sealing rings that were in there. Hopefully this shows up the way they are made. See how they fit together right there? You cannot separate them to take it apart that way. You actually have to pull it out this way to get them apart. But before I put the new ones in, because I'm going to be monkeying around in here, I'm going to go ahead and stick some components in. I've got my new seals on this piston. It's going to drop in there. Try to keep my head out of the way. I need to rotate it and get it going in that bore. Looks like it's going. Okay, I believe that's seated. Now this spring retainer goes on next, and then it gets followed by this snap ring. This is going to be another fun situation, and I really don't think I'm going to be able to at least attempt this, because I am going to have to get over here. So I'll go ahead and do that and then describe what I had to do to get that on there. Alright, well, I'm going to try to go ahead and show this. I've got the snap ring down close to where it goes, so I'm going to use 2 screwdrivers and try to push down on this and push that snap ring down as I work around. Almost got it right there. Try this edge. You know, I don't know if you can see what I'm doing, but trying nonetheless. I actually did get it. That is definitely in there. Okay, that wasn't too bad. Alright, well, I need to get these sealing rings down in here. I'm going to try to shoot this in real time, but it is a tight hole. I will say that. I'm going to try to separate them just enough to get down in here. I can't even see what I'm doing. I'm just going by feel. I'm trying to get past the first groove. I'm kind of hung up. Okay. Now I'm working into the bottom groove with this ring. I believe. Yeah. Okay, I got it in the groove. So what I'm going to try to do here is catch this one right here and bring it to the outside. Missed it. And try to push this over and get it snapped in. There it went. Okay. I'm trying to show this, but I know it is not working out. I'm getting into the groove. I'm working this section here out and then coming in and catching that like so. Okay. Not easy to see, but that is what I'm doing. So now I'm trying to work this one in. Boy, it is tight in here. Okay, I went a little bit too far down on this one. I'm trying to back it up in. Okay, now I got this in that groove. Going to try to attempt to do the same thing. I've got the split right over here on the side. I'm pushing in with my index finger, and then I'm going to try to pull this side out or keep it out while going in. Okay, I got that one too. That wasn't too bad, even though you can't tell what I'm doing. Now I'm going to take a little bit of trans gel and coat these rings so when everything goes in there, they'll slide in position the way they're supposed to be. That's the plan anyway. Okay. Moving on. Alright, well again, the manual is incorrect. They're calling for 3 frictions, 3 steels. There are 4 of each. I'm going to start with a steel here. There's a area that's cut out right there. That's where the steel will drop in. This is way down in a hole, and I'm trying to keep my head out of the way. Okay, there's one. And then a soaked friction will go in here. Another steel should go right like so. Friction. Same principle as before. Go in like this. Friction. A steel. The last friction. Then the selective plate will go in. Like so. Then we've got a snap ring to get down in here. I am going to try to do this from my vantage point, but I really need to get over this. You've got a better vantage point than I do, I assure that. Well, it is going. Okay. I can at least see this section right here. Alright, well, to check the travel on this group, you're supposed to set up a dial indicator and apply 60 pounds of air to a port and then read the travel. They didn't really say which port it was, but it's this one right here. Alright, well, I've already done this and worked out my math. I'm out of specs, but I'm going to go ahead and show this. So I'm at 89 thousandths. Yeah, and on the high end, I should be at 81, so I'm 9 thousandths out of spec. Well, here's my problem. My plate I've got in there is 127 thousandths, and the next increment is 134, but I can't get a plate from my supplier, so even if I could, that would put me at 82, so I would just be a thousandths over. I'm going to stick the other pack in and see what it reads, the original pack and steels. Try to use that as a comparison. Alright, well here's the results that I get with the original clutch pack installed. I'm at 74 thousandths. Yeah, 74. So that's right at the tolerance right there.